Right, so over to you, Alex.
Okay,
Have some
it's
fun.
going to be a little bit of an experiment, as the title says. I've got different stuff prepared here, and I hope everything is going to work. So, how to interweave science into language teaching? You might be asking yourself, and I'm going to give you suggestions if you were into something like that. If you've never thought about that, maybe that would be something that inspires you. Well, that was a very good question from Ella. This is Toruń, but at the moment I'm in Sheffield, spending COVID times here. Now, the person that is connected with my city is Nicholas Copernicus. So even if you haven't heard about Toruń, I suppose you have heard about Copernicus. I could talk about him for a while, but Ella hasn't given me too much time. So Copernicus maybe some other time. So yeah, who am I? So I'm a geography teacher and an English teacher, and this is what I did at the beginning, teaching two subjects separately in a high school in Poland. And then I started to be involved in bilingual education. So I started teaching geography in English or through English in bilingual programs in lower secondary and secondary school. And from there, I went into teacher training, and originally it was teacher training for geography teachers only. And now I'm involved in teacher training of primary teachers, secondary teachers, English teachers who are interested in CLIL, irrespectively of the subject or topic they are interested in. The idea that I've been kind of promoting recently is the CLIL wheel that combines traditional 4Cs of CLIL, so communication, content, cognition, and culture, with so-called 10 CLIL parameters. Again, I could talk for a while about all this, but today, and my motto, my icon of CLIL matters is just using this wheel. But today I would like to concentrate on so-called 3 dimensions of CLIL. As you see, this parameter goes between content and communication because those 3 parameters include content and language, and the third element is procedure. I don't want to talk about everything. The most important thing here is that those 3 elements have to be tuned in, that is properly adjusted to the situation or to the student's level. But now I'm going only to look at content and language, because very often we face the situation that, yes, the content is great, but the language is too difficult, or the other way around. So what can I do to make sure that my students follow the language, but are also okay with the content? So I designed something like that. Originally, we talk about high and low content demands and high and low language demands. But in my teaching and teacher training practice, I thought that I need this medium level as well, that it's not really okay to go from low to high, that I need a stage in between. That's why this kind of 3 levels, I would say, of language demands and 3 levels of content demands. But if you look at the structure, you see that the color, the darkest color, is in the top right corner. Because this is where it is really challenging, where the content is really demanding and the language is demanding. So I'm going to present you with an experiment. I hope it's going to work. And I'm going to be showing this table and kind of trying to see where we are in terms of the language and in terms of the content. So I would like you to look at this typical language activity. I've got the beginnings of the sentences, questions, and I have to match them with the endings. So this is a language activity. Of course, if I do this with my students, I need to make sure that this is the level for them. So take a moment. How many? Okay, how many plastic bottles? And then the next one is how much water and oil. So of course I look here at countable versus uncountable. What is the plastic cup for? What color? I'm helping here with using the word food coloring and giving 2 colors. So what color food coloring will we use? Blue or red? Where will we get the effervescent tablets from? And I accept that my students may not have heard about effervescent, this word, but I suppose tablets would be okay. And even if I have a question, oh, miss, what is this? I said, okay, you can try and do it without knowing this word. You really need to know this word. So this is also a way of showing the students that they can do an activity like this correctly without knowing every single word. And the last one is, should we add a whole one? So linguistically, it's at the student's level. Even if there is this one word that is new, I know they can do it, just looking at the language. So going through this activity, I've got 6 questions with vocabulary that shouldn't be generally an issue. So the next stage is to match those questions with the answers. Okay, so let's look at those. There is a question, there is an answer. How many plastic bottles do we need? And again, I'm looking at grammar, how many? And I've got just 1, but it should be rather tall. How much water and oil do we need? 2 centimeters of water and 10 centimeters of oil. I understand that talking about centimeters here, it's not very precise. Chemistry teachers, science teachers could scold me for being not that precise here, but it is okay for my context. What is the plastic cup for? For mixing the food coloring with the water. What color food coloring will we use? Any, but just a few drops. And where will we get the effervescent tablets from? I've bought some at the chemist's. And should we add a whole one? No, just half of it to start with. So I've got this dialogue. I've got questions, I've got answers. I can do everything looking at the language, really. So where am I here with the content demands and language demands? I would say I'm really here. I'm not challenging the students in terms of chemistry, not yet. I'm not challenging my students with the language. I prepared the activity on the level that I know is their level. Okay, so what next? What do I do with this dialogue? So I've got this dialogue, and I would like my students now to take information from there and tell me what I should do. What do I need for the experiment, and what I should do with the stuff that I have. Okay. I suppose you can tell me, just looking at this dialogue, you can tell me I need a plastic bottle. It should be tall, rather tall. Okay, 1. I need some water. I need some oil. I need a plastic cup. I need some food coloring, and I need some effervescent tablets. Okay, so these are the ingredients of this experiment. Now, what's the procedure then? What do I need to do? I've got this sentence, mixing food coloring with the water. Actually, what I have prepared here, this is food coloring mixed with water. It's dark red color, purple. Okay, I've got I need a plastic bottle with some oil. This is my fancy shaped plastic bottle with some cheapest cooking oil I could get. Okay, and I need tablets. Yes, I got some tablets here. Yes, effervescent tablets could be different types. These could be effervescent vitamins, but they very often have got strong color, like orange or yellow, and this messes up with the food coloring. You could use Alka-Seltzer or any other stuff that is effervescent. Actually, this is an interesting thing. These are tablets to clean false teeth or dentures. And I use them because they are cheapest, plus they are white, which means they don't change the color during the experiment. Okay, so based on this dialogue, I would like my students to be able to tell me, 1, what ingredients go into the experiment, and 2, what I should do step by step. Okay. I can divide this experiment into 2 stages, and I can hypothesize. I want my students to tell me what they think is going to happen. So I've got the first hypothesis written here. What is going to happen when we add colored water to the oil? And the second, what will happen when we add a tablet to the oil and water mixture? Well, depending on the student's age, you can get really interesting answers to the first one, for example. And I don't only mean that the children aged 8 or 9 would have a problem telling me what is going to happen when you mix oil with water. I use this experiment with grown-up people, teachers in teacher training, and you can really be surprised hearing discussions between grown-up people. Some would go, oh, water is going to stay on the top of the oil. No, water is going to get to the bottom. No, water and oil are going to mix. This is something I can get from my students. And again, with the second one, I can also gather different hypotheses connected with the experiment. Now, what I'm also trying to do here is to bridge something that is called BICS with something that is called CALP. So BICS is basic interpersonal communicative skill. This is this everyday language that students come to my science class with. They know the words oil or water, but they may not know the words like hypothesis, for example. And hypothesis or hypothesizing is CALP, so cognitive academic language proficiency. I want them to know and understand and use academic language. So I'm using those grammar structures that are easier. What is going to happen, or what will happen in a situation when I'm introducing the word hypothesis or hypothesizing. I'm trying to show my students, okay, I know you know this word. Now, from time to time, we are going to be bridging between BICS and CALP, so that at some point, I just start using what is your hypothesis here or there. So these are those 2 grammar structures that are simpler. Okay, so what we have done in this process of hypothesizing and me getting answers from the students, I can write down all the suggestions. I won't tell them, yes, you are right, or no, you are wrong. We've moved a little bit up in terms of the content, because now they have to think about the interaction between 2 liquids, or 2 liquids and a tablet, that they may know or don't know how it's going to react. So we moved a little bit up with content, and we moved a little bit up with the language. I decided not to put this second cross in the medium language demands, because we are still using the same language that the students know. The only difference is the word hypothesizing or hypothesis. So a little bit up, but not too much. So, okay, you can imagine I've got now those different ideas from my students. I wrote them down. Now I need to conduct an experiment, and I need to observe. I listened to the previous presentation, and there were online tools for voting. So I think that would be a good situation now. Okay, so what do you vote? What is going to happen? That's just an idea I had from the other presentation. So now I need to conduct this experiment. Okay, so I've got this oil here. Okay, and I've got this food coloring. Okay, so can you just tell yourself, okay, what is going to happen? Is this colored liquid going to stay on the top, at the bottom, or what is going to happen? This is what is going on. So you see that water with the food coloring is going to the bottom. Okay, so now I can get, you know, we've got observations, so I can get feedback from my students and see, okay, so who was right, who wasn't, and then ask this question: why is this liquid at the bottom? Why is water? Actually, this could be just clean water. We don't need the coloring. The coloring is for fun, or for more exciting outcome. So this is the first stage. They observe that the water with the food coloring stays at the bottom. They can give me their ideas. I expect words like heavy and light. These are the concepts that students, I would guess, already understand, even if they are 8-year-olds or 9-year-olds. And now the question is, what is going to happen if I put the tablet, and of course, if I read the dialogue properly, I understand it, I know I should use half to start with, because this is what we had in the instructions. So again, what is going to happen? And I heard different ideas. Like the color is going to change, it's going to blow up, various ideas. And of course, the big thing is just to do it and wait. I hope you can see it. You can see what is going on. You can see movement inside. Because the tablet, of course, this is an effervescent tablet, so the tablet is dissolving in the liquid at the bottom, and there are bubbles going up. Okay, of course, if you do this in classroom, and actually I did it in a language school in Torun with 8-9-year-olds, and I had 3 bottles, and they had fun. You have to be careful, because some of the students would be very eager to, you know, drop as many tablets as they can inside, and then, you know, it can really go over the top, and you can have a lot of foam. So I've got this process going on. These are my observations. So look what I've already got on this slide. We are talking about conducting an experiment and conducting observations, which is also academic language. But of course, I want to know why those things are are happening here. Can you explain? I'm going to put it away, and we will look at the follow-up. Okay, so we've got the experiment, students can observe, and now we want to explain and understand all the processes going on. So I've got here another language activity. I've got 6 sentences, and they are, in terms of the content, in terms of their meaning in science, they are correct, but there are some grammar mistakes. Well, I understand that not everyone likes giving sentences with mistakes to the students because they may not be an effective tool in looking at the language. But here, I'm kind of trying to move the students' thinking from the content to the language only. And the content comes like together. So of course we've got little things here and there, a missing s, third person singular, or a preposition. I'm giving suggestions to my students. There is just one mistake, and in the other ones I say, okay, there are 2 mistakes. So I'm kind of supporting them in this activity. But by looking at and looking for the mistakes, looking at that, they also read the sentences and kind of familiarize themselves with the meaning of those sentences. Again, here I'm trying to bridge bigs with calp by putting the words heavy and dense together. This is because I understand that my students know the word heavy and understand this, but they have not heard, and they may have a problem with the word dense. Okay, so, okay, I've got those 6 sentences that they have been corrected. And now the next question is, which of them talk about oil in my bottle? Which of them talk about water? And which of them talk about gas? Because by that time, I know that, and we have come up with the idea that those bubbles, that this is gas. I don't need to know what type of gas it is. It's at this level, at this stage, for me, it is important that they understand that there are 2 liquids and gas. So of course, we can look back into at our experiment. It moves up, so that's gas. It stays on the top of the water, it's oil. It stays at the bottom of the bottle, it's water. So I'm only talking about the kind of position in the bottle. But now I'm going to look at light or heavy with the word dense, because actually what I'm trying to teach is the concept of density. So I'm going to start with, it is very light and not dense. It is very light and not dense. It's gas, it's very light, so it moves up. And I'm also saying or giving this notion that it is not dense. Then the second one is going to be water. It is very heavy and dense. So this medium, it is not that heavy and dense, is oil. So again, I'm kind of trying to bridge everyday language, concepts that students know, like heavy and light, with the academic terminology like dense and density. So what has happened here? Well, I moved up both in terms of the content and in terms of the language. It is still not the highest level of both, but I moved up. The thinking behind those sentences is the content, the language. I have introduced this word dense. It is because the whole concept here is density. So now I'm introducing the proper definition of density. It is weight per volume. That is density in kilograms per cubic meters. So this is proper academic language. This is proper academic concept that I want my students to understand based on this experiment. So again, this is a language exercise. I can make it a little bit less challenging if I give a list of words that go into these gaps. I can make it more challenging if I don't give those words and the students have to come up with their own ideas. These are, typical tools in the language teacher's repertoire. So this is a completed sentence or text. Oil looks and feels heavy, but if we measure its weight per volume, that is density in kilograms per cubic meter, we see it is less dense than water. This is why it stays on the water. Water stays at the bottom of the bottle as it is denser. Gas is not very dense, so it moves quickly up the bottle. So here I use only the word heavy once, then I use my academic terminology, density, weight per volume, kilograms, cubic meters, and so on. So what has happened with the language and with the content? We moved to this highest level of demands. The language is demanding and the concept is demanding. But you can imagine if I try to teach this concept of density by giving a definition first, I might put the students in a situation when both language and content are too demanding, or one of them is too demanding. Okay, so I've got a proper handout that you can use if you are interested in that you can use with teenagers, but I also use this experiment with 8-9-year-olds in a language school, and it was very much controlled. You see the posters that they made, ingredients, hypothesis, then observations, then second hypothesis, and more observations and conclusions. So you might say, why teach this academic language? They are just 8 or 9 years old, but I don't see the reason why not. They are intelligent young people, and if you support them in acquiring this language, academic language, they will manage. But of course, there needs to be there must be recycling of this language. We had games like here, where I put a scientific experiment in the middle, and they were to use words from the whole activity, creating their own crosswords, and we put an alphabet. Okay, do you know any words that start with those letters as a revision? But it was just one lesson, and what I would like those students to really acquire this language. So next lesson, the next experiment. You see 3 bottles and 3 balloons. The balloons contained baking powder, and 3 bottles contain different acids. So we had vinegar, lemon juice. Gosh, I don't remember the last one, but the question was, which of those mixtures is going to produce most gas? And you see the blue balloon, I think it's vinegar, the blue balloon is the biggest. And so that was the second lesson, when we could revise the language, like, okay, what's your hypothesis? Let's observe. What are our conclusions? And the next one, another one, is about sinking and floating. So we've got different objects. I brought them to the classroom: styrofoam, pencil, cork, candle. So you see there is a lot of vocabulary, but the students had to predict whether something is going to float or sink. We had a bowl with water. There was a lot of fun. And as you see, we made a Venn diagram, putting some stuff here in between. Okay, so recycling is important. What are other options that you can use if you want to do a little bit more content? You can extend your course book. For example, you talk about food or clothes in your courses. So why not moving into sustainable development from there? You can use CLIL pages if your book already has CLIL pages, but it would be good to extend it into a few lessons. Or you can explore CLIL readers, like this series by Express Publishing. And then what is a good thing about that is that they tell you the language level. But I would kind of encourage you to go beyond the CLIL reader and reach into subject areas that are not obvious. For example, these are photos from one CLIL reader by Express Publishing on ancient Egypt, but there are connections with other subjects, like talking about the Nile. That's geography. Go beyond what is in the book. Talking about the Egyptian god Ra and their understanding of astronomy, go into the astronomy. Counting, 365-day calendar, you can go into maths. Talking about Sphinx, limestone, okay, so geology, but also art. Mummification, that's biology. Different organs, what do they do with different organs? Building pyramids, you can go into geometry, but also physics, like pulling objects. Talking about agriculture, wheat, okay, what's the situation with wheat production now? So geography again. So content, or also called content enhanced language learning, can give you endless options. And being language teachers, you are in this position that gives you more flexibility than so-called hard CLIL teachers when you have to follow the subject curriculum. I'm present on social media, CLIL Matters. You can find us on Facebook groups for primary and secondary teachers, on YouTube and on Instagram. And if you are interested in any CLIL matters, get in touch. One of the things that I can offer is the handout, 2-page handout, where the students, like teenagers, make this experiment with a lava lamp on their own. Okay, that's it from me. I'm just